This is your lesson on arithmetic and geometric series. It's going to follow the notes found in Glencoe 11.2 and 11.4. Let's take a start with example number 1, where we're to find the sum of the first 100 positive integers. So let's first remember what integers actually are. Integers are whole numbers, so the first 100 positive ones are going to be 1, 2, 3, 4, and so on, creating what our arithmetic sequence here is. So first off, the sum formula. Sum just means add all the terms. Rather than adding all these terms together for 100 different terms, it's a lot easier to use a sum formula. Let me rewrite what the sum formula is for arithmetic sequences. Arithmetic sequences, we have n over 2 times the quantity of a1 plus a sub n. Now, it's important to recognize that this n here in our formula represents the number of terms I'm finding the sum of. So I'm finding the sum of the first 100 terms, so there are going to be 100 terms in my series. Cut that in half. The very first term of my series is going to be 1, and the very last term at the end of these first 100 positive integers is going to be 100. So really now it's just going to take some solving. I'm really going to do 100 over 2, that's going to give me 50. And 1 plus 100, that's going to be 101. So then we just have 50 times 101, and that gives us 5,050, which is the sum of the first 100 positive integers. Now let's take a look at this real-world problem here. All right, a radio station considered giving away $4,000 every day in the month of August for a total of $124,000. Instead, they decided to increase the amount given away every day while still giving away the same total. Key word here so far is total. Total will probably mean sum. If they want to increase the amount by $100 each day, here's our common difference. How much should they give away on the first day? This tells me we do not know A1. All right, information we do know. We have a total of $124,000, okay? We know that we want to give away $100 each day. And we know that we are in the month of August, so we need to think about how many days there are in August. There are going to be 31 days in the month of August, which means our n value is going to be 31. So let's write out what the sum formula is once again. So the sum of n equals n over 2 times the quantity of a1 plus an. All right, now, things to observe. We don't know a1, but we also don't know what our nth term is. So I want us to think about what we know. Is there any expression we can substitute in for an? Why, yes, we can substitute in our formula for arithmetic sequences. So our formula for arithmetic sequences is a1 plus the quantity of n minus 1 times your common difference. This is the formula that your textbook is actually using, and I just wanted to show you where all it was specifically coming from. So let's plug in some information. We know n is going to represent 31 days in the month of August. I have 31 over 2 here. All right, the next thing we're going to make the observation of is that we still don't know a1, but we're going to get to combine him with the other a1 inside our parentheses, giving us 2 a1s. We can also substitute in 31 right here, our 31 minus 1 quantity. So that's going to be plus a total of 30. And our common difference is the $100 we're giving away each day. So here he is right here. Let me zoom out. All right, so now I'm really just going to continue simplifying my expression. The sum here, remember, the sum was $124,000. So now we're really just going to start simplifying our answer here, okay? So we still have 2a1 plus 3,000. To get rid of this 31 over 2, what I'm going to do is I'm going to multiply both sides of my equation by the reciprocal of 31 over 2, the reciprocal being 2 over 31. So now the right-hand side will be set equal to 2 times a1 plus 3,000. 124,000 multiplied by 2 over 31 is going to simplify to 8,000. Essentially what we just did was we multiplied by 2 and divided by 31. Alright, so now we just need to isolate the variable that we're looking to solve for. So we're going to subtract 3,000 from both sides. That's going to get me 5,000 is equal to 2 times A1. Now we just need to divide. So then we find out that our A1 is going to be equal to 2,500. And that was all the question was asking for. But it was asking for a dollar amount, so I'm going to be accurate and give a dollar sign. Alright, we're about to finish up arithmetic series, but let's do example 3 before we are completely done. In example 3, I'm given a variety of information, and it's very evident what I'm not given. So I'm supposed to find the first 3 terms. Well, I have the first term, so if I knew what the common difference was, it'd be really easy just to find the next 3 terms. So I don't know what D is equal to. Another obvious thing that I don't know is value for n. I know what the nth term is. I know what the sum of the n terms are, but I don't know what n is equal to. So it looks like I'm missing a lot of information. Notice that with the sum formula for arithmetic series, the only information I need is the first term, the nth term, and my total. And then I can solve for n. So I'm going to plug in 741 for my sum. Don't know what n is. My first term is 9, and my nth term is 105. So notice that I have enough information now to solve for n. So all I need to do on this right-hand side of my equation is add 9 and 105, and that's going to get me 114. Then I'm going to cut that number in half, essentially. So I'm going to take 141 and divide it by 2. So 741 is equal to, well, half of 114 is going to be 57 n. Okay? So now all we got to do is divide both sides by 57, and we get that n is equal to 13. So the 13th term of the sequence is 105. But what's the common difference? Well, here is our formula for an arithmetic sequence. So now we have enough information. Our nth term is 105. Our first term is 9. The nth term is located at spot 13. And now we can isolate our common difference. So first off, let's notice the fact that 13 minus 1 right here is 12. So we really have 12 times our common difference. We can also decide before we move on to subtract 9 from both sides. 105 minus 9 is going to get me 96. So right now we have 96 is equal to 12 times our common difference. We're going to divide both sides by 12, and 96 divided by 12 gets me a common difference of 8. Believe it or not, we are still not done with the problem. The problem asks for the first 3 terms. So the first term of our sequence is 9, and now we need to find the second and the third. To find the second term, I'm just going to take 9 and I'm going to add 8 to it. 9 plus 8 gets me 17. Now, to get my next term, I'm going to take 17 and I'm going to add 8 to that, and I'm going to get 25. The last topic in this section that we need to look at is what is called sigma notation. Please note that there are going to be 2 different approaches to this problem. What sigma notation really means is find the sum. Find the sum from whatever term the bottom of our sigma notation tells me to start at, all the way up to the term he tells me to end at. So one way of looking at it is we're going to start at the 5th term. So I'm going to need to plug in 5. And I'm going to go all the way up to the 8th term. Okay? All these terms I'm going to have to add together. So realistically, the only ones I need to plug in also are 6 and 7. Okay? And then I'm going to find what each of those values are equal to. Well, 3 times 5 is 15. 15 minus 4 is 11. 3 times 6 is 18. 18 minus 4 is 14. 3 times 7 is 21. 21 minus 4 is 17. 3 times 8, that's 24. 24 minus 4 gets me 20. I'm going to add up all these terms because we're going to find the summation, and sum means add. 11 plus 14 plus 17 plus 20 gets me 62. Now this was a really easy method, okay? Now when it starts to get bigger and more complicated, when there are more terms, it's going to take more time. So another way for us to approach this is by using our summation formula. So the sum of n terms is equal to n over 2 times the quantity of the first term plus the nth term. Now in this scenario, I'm going to let the first term actually be the fifth term, okay? We're going to let that happen. And the nth term is going to be my eighth term. Now we've already identified what the first term is. The first term is 11. We got that right here by plugging in 5. Our nth term, he's 20. We got him by plugging in 8, okay? Now here's the tricky part. How many terms are there between the fifth term and the eighth term? Well, we counted it out ourselves over here. 1 term, 2 terms, 3 terms, 4 terms. So I'm finding the sum of 4 terms. So now it's just going to be some simple algebra. 4 divided by 2 is 2. 11 plus 20 gets me 31. 2 times 31 gets me 62. And notice we got the same answer. All right, we're now taking a look at geometric series. And our first problem is actually a real-world problem, so make sure you read it very carefully. After reading it, hopefully you notice that the number 15 stands out. In the context of this problem, where I'm looking for the total number of ancestors, I'm dealing with a sum. And the total number of terms that I'm dealing with is going to be 15. All right? Let's think about what this sequence really looks like, okay? So, counting your 2 parents. So let's see, we have a mom, a dad. Maybe that's not what your family looks like. Each of those parents comes from another set of parents, okay? Here are my terrible stick figures on the iPad. All right, so notice, by drawing this diagram, what I just recognized is we started off with 2 parents, and then we ended up with 4 grandparents. Then, if we were to keep these going off, we would end up with 8. So what we can just identify now is what is called the common ratio in our real-world problem here, okay? So n was 15. Our common ratio is going to be 2, because we're going to multiply that number by 2. And now we can just find the sum. The sum for geometric series has a different formula. The sum of n terms is equal to a1 times the quantity of 1 minus r to the nth power over 1 minus r. So a1, we're going to let a1 be your parents. So the 2 parents, 1 minus, our common ratio is going to be 2. We're going to raise that to the 15th power and putting that over 1 minus 2. Okay. At this time, this is just a spot where you can type this quantity into your calculator, but let me caution you with how you are typing these things in. Don't let your calculator make you seem silly. 2 to the 15th, you need to do your exponents, and then you would multiply by the subtraction out front, okay? So if you type this in, make sure you're checking your work, you get 65,534 ancestors, okay? All right, let's look at another sigma notation problem here. Remember, one of the most basic ways to approach sigma notation is actually plugging in all the terms that we are being asked to in this particular problem. So in this problem, we're told to start from the first term to the 6th term. And so what that would look like is plugging in 1 all the way up to plugging in 6, okay? So I'm going to let you finish up that first method if that's the approach you prefer. But I'm going to go back to using the sum formula for geometric series. Notice that our formula is slightly different than that of on your Quality Core formula sheet. With the only difference being the fact that they have A1 distributed into that quantity in parentheses, which is perfectly acceptable. I just prefer to leave it out. Something that I want to point out is when I look at sigma notation for a geometric sequence, all I really need to do is identify the components of its equation. A1 is going to be the 5, okay? So I just have to plug that in for A1. The R is clearly identifiable as the 2. And the N for my series, I just need to recognize between the first and the sixth term, there are a total of 6 terms, okay? So now this expression here, you can either just type it in your calculator or you can break it down yourself. Regardless, you're going to find a sum of 315. All right, in our next example, we are going to use what is called the alternate formula for a sum of a geometric sequence. I do recommend making sure you're reading the textbook very carefully. It does actually walk through as to where this formula comes from. So here is the alternate formula. The sum of n terms is equal to a1 minus a sub n times your common ratio over 1 minus r. This formula is going to be useful in this scenario because I'm given the first term, the nth term, and the common ratio. Don't even need to figure out what n is. All right, so let's just plug in our information. A1 is 15,625. We're going to subtract the quantity of -5 times our common ratio of -1/5. And this is all going to be over 1 minus my common ratio of -1/5. Okay? Be very, very cautious with your signs here, especially if you're just typing this into your calculator. When you do, you should get a sum of 13,020. On to the last example here. I am told to find the first term of a series given the sum of 8 terms and a common ratio of 3. Once again, I really do find it helpful to actually write out the sum formula so I can figure out what information I have and what information I do not have. So notice here the information I've been given. Discretely, I've actually been given Rn. Notice it's the sum of 8 terms. So Rn is 8, okay? This total is going to be 39,360, and my R is 3, leaving me with the only piece I don't know of A1. So now let's just get started in plugging in what we know. So 39,360 is equal to A1 times the quantity of 1 minus 3 to the 8th power over 1 minus 3. All right, we just got to start simplifying this now. On the bottom, we have 1 minus 3. So we have 39,360 is equal to A1 over 1 minus 3 is -2. The quantity of 1 minus 3 to the 8th is going to produce -6,560. Now I'm just going to divide these. -6,560 divided by -2 is going to produce 3,280 times A1. Okay? Now lastly, to divide away 3,280 from both sides, giving me an A1 value of 12. Okay? Not a lot to it.